Hello there. My name's Samuel James. I just wanted to start off by saying I am not a chemist. By trade, I am a nurse. So I wanted to start off with that. This is week one of the interactive presentation. I've got my pepper, my salt, my balloon, and some hair to rub the balloon against to hopefully generate a negative charge on the surface of the balloon. So to start off, I'm going to standardize my measurement of the pepper so that there are equal parts pepper and salt onto the plate, mixing the two. So, salt, sodium chloride, is technically a compound. Every compound has equal parts to it. Equal parts sodium, equal parts chloride. Chloride has a negatively charged, is a negatively charged particle, sodium being a positively charged particle or ion, called a cation, chloride, an anion. The pepper, we don't know for sure what its net charge is, but here we go. I'm going to rub the balloon against my hair, hopefully generating a negative charge. As I'm doing that, I'm going to mix these two up, the salt and the pepper. Let's see, let's zoom in. And I just sit this over top of the mixture that we just made. And we see that we were able to generate a negative charge with the surface of the balloon. I see no sodium chloride particles, but I see pepper sticking, letting me know that we had a successful procedure, experiment, if you will. So a few of my takeaways as we get this camera more situated. A few of my takeaways. The table salt is a compound. We know there are equal parts sodium, equal parts chloride. Those are the two particles, if you will, elements in the compound. Let's see. I'm thinking, my hypothesis is that the pepper must have a positive, a net positive charge, because by rubbing the balloon on my hair, we generated a negative charge. And as we know, principles of chemistry and static electricity tell us that positive and a negative attract. So I would have to look up the different additives in pepper, but I would say, I would go ahead and make the claim saying that pepper has a net positive charge because we created a negative charge on the surface of this balloon by rubbing my hair. Had this not worked and the pepper had not been attracted to the negative surface of the balloon, I think that some of the factors that would have contributed to a failed experiment would have been maybe there was some sort of moisture, which I'm sure there is because we keep these open in my house. Probably some moisture in the bottles here of the salt and the pepper. What is moisture? Moisture is H2O. A water molecule doesn't have a net charge to it, positive or negative. It's a polar covalent bond, so the particles kind of sit on either sides of the molecule from each other. giving the name polar covalent bond. But as a whole, the molecule doesn't have a positive or a negative charge. But nonetheless, maybe extra moisture on the plate, maybe moisture in the pepper or the salt could have affected the experiment, yet we were able to generate enough of a negative charge on the surface of the balloon to attract a somewhat positive charge particle within one of the ingredients of the pepper. And let's see where we're at. So that puts us at about 6 minutes. Given my basic chemistry knowledge, that's about my best attempt at this, and I feel like it's a good one. The experiment seemed to work. We proved that opposite charges do attract. And my claim, or my hypothesis beforehand, was that pepper must have a positive charge because we were generating a negative charge on the surface of the balloon. And that is why the two were attracted to one another. This is Sammy James once again, closing out. Thank you, and this was week 1 of the interpretive presentation. Bye-bye.